Well, let's go through this worksheet together for Unit 11A. So the first question is, which of the following is an example of exponential growth? And it's C, the increase in frequencies and scale, if you recognize that as an exponential equation. Number 2, what are the most pleasing combinations of notes? And it turns out it's consonant tones. So look that up. They are the most pleasing combinations of notes. Good harmony. Number 3, which of the following is a method of storing digital music? And that would be a compact disc. Number 4, what types of instruments create music digitally? Well, synthesizers do. Starting with the tone having a frequency of 118 cycles per second, find the frequency of the tone that is 2 octaves higher. Well, here's what we're going to do. We're going to double 118 and then double it again, and when you do that, you get 472 cycles per second, which is C. Every time you go up an octave, you double the frequency. Now, number 6, find the frequencies of the first 6 notes of the scale that starts at the given note, D above middle C. So we'll start at D, and it has a frequency of 292 cycles per second. Notice we can use this chart to do that. Then D sharp has a frequency of 309 cycles per second. E has a frequency of 328 cycles per second. F, a frequency of 347 cycles per second. F sharp, 368 cycles per second. And G, 390 cycles per second. I think that's 1, 2, 3, 4, 5, 6. Yeah. And was that D above middle C? Yeah. Did it. Okay, for 7, starting at middle A. Okay, we'll start at middle A. Find the frequency of the note 5 half steps above middle A. Okay, here's middle A, 5 half steps above. So we don't count this C, we're going to dive right back up there to that C. Above middle A. Was that 5 half steps? Let's double check that. 5 half steps, yeah. So we'll go to A sharp, 1, 2, 3, 4, 5, D, but now we're going to double 292 because we're an octave above this. And when we do that, we wind up with C, 584 cycles per second. Now let's do 8, and I hope you see how to use this table. It's very handy. Starting at middle C with a frequency of 260 cycles per second, find the frequency of the note 36 half steps above middle C. Well, that's 3 octaves. So we're going to double 260. Then we're going to double it again and double it again. And when we do that, we get A, 2080 cycles per second. Now 9, starting with a tone having a frequency of 127 cycles per second, find the frequency of the tone that is 1 octave higher. Well, we simply have to double 127 and we get 254 cycles per second. That's C. For number 10, find the frequencies of the first 6 notes of the scale that start at the given note. Okay, G sharp above middle C. and we're going up the first 6 notes, yeah, G sharp. So there's the first one, 413 cycles per second. At A, we're 437 cycles per second. A sharp, we're 463 cycles per second. B, we're 491 cycles per second. Let's see, that's 1, 2, 3, 4. If we double 206, then we go to C, which is 260 cycles per second, but we have to double that because we're an octave higher. So that's going to be 520 cycles per second. Finally, the 6th note is C sharp. We're at 267 cycles per second, but note, we have to double that because we're an octave higher. So that's going to be 550 cycles per second. Hope you catch that pattern. Now let's do the final question. And it says, the circle of fifths is generated by starting at a particular musical note and stepping upward by intervals of a fifth. Well, a fifth involves 7 half steps. By what factor does the frequency of a tone increase if it is raised by 3/5? Well, let's keep in mind a fifth. Count the number of half steps from C. 1, 2, 3, 4, 5, 6, 7. There we traveled 7 half steps to get to a fifth. So we've got to, if we're going to get to a fifth, and we're talking about the square root of 2, by the way, when we find the number of the change in frequency, don't we have Q equals Q sub aught times 2 to the 12th root of 2, and now we've got 3/5. Well, there's 7 half steps in a fifth. 3 times 7 is 21. And there's the factor that's going to multiply the initial cycles per second. That's what we're going to multiply those cycles per second by. And it turns out that is B when we carry that out. 3.36. That's the factor. And we're done.